Alright, so 1.6, which is, I'm pretty sure the last section in this chapter. So I'm looking at probably a test on maybe Friday. Here we'll see probably quiz on, well, I don't know, maybe quiz on Thursday. Since this is an AP class, it should be over 2 sections, so it shouldn't be too bad. But I'll have to look and see. I kind of went through the test calendar a little bit ago, but I think I changed a few things, so I need to look at that. But anyways, 1.6, trig functions. So the formula for arc length spell what is going on is S is equal to R theta remember that theta must be in radians for that formula. Let's see. R is radius, and X and Y are the coordinate axes. So sine of theta is equal to Y over R, cosine theta, X over R, tangent of theta is equal to Y over X, cosecant of theta is equal to R over Y, secant of theta is equal to R over X, and cotangent of theta is equal to X over Y. The next thing we're going to kind of do with this is we're going to look at the graphs of trig functions, okay, what the parent function looks like, and then what's true about its domain and range, and the period of it, okay, so like repeating wise, like what that looks like. So let's see. I'm gonna try to I'm gonna divide it up. I'm gonna need 6 total, but I'm gonna get 4 on here right now, and then I'll get the other 6 in a minute, or the other 2 in a minute. So up here, I'm going to have y is equal to the cosine of x, and then in this one, I'll do y is equal to the sine of x. All right, so remember on these ones, okay, up and down, okay, on the y-axis, it goes from -1 to 1. That's always good. All right, so remember for cosine, we start up at 1, and then we work our way down and back up. And then we also do it in the reverse direction. Now, what would the domain be for this function? What x values does this take up? Negative infinity, less than x, less than infinity. And then our range is just going to be from -1 to 1. And we want to know at what point it starts to repeat, okay, when we're talking about the period of it. So for this one, it is 2 pi. And obviously we know sine is going to be very similar. It's just going to be starting at 0 instead of at 1. I'm not going to label all of these points because I don't need to. So the domain, range, and period are all the same for sine. All right, so I don't know if you remember what with, hold on, that's the wrong thingies for that one. But tangent and cotangent have asymptotes on them. Tangent and tangent has them at pi over 2's. Okay, so we put the dotted lines there. tangent looks something like that. So for the domain for something like this one, it's basically all values of x except these pi over 2 increments. So we can just put x not equal to plus or minus pi over 2, comma, plus or minus 3 pi over 2, comma, dot, 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 okay. It'll just be at all of those values. The range, it literally covers all y values, so negative infinity, less than y, less than infinity. And it has a period of pi. The cotangent one has the asymptotes at the pi's, okay, and right at 0 as well. And it goes the opposite direction of tangent. So the domain for this one is x not equal to 0, plus or minus pi, plus or minus 2 pi, etc. The range is, again, negative infinity to infinity. And the period for this one is 2 pi. Or wait a second. Let me check that. I think I have that written wrong. I'm pretty sure that's pi. Yeah, I have it written wrong. That's pi. Are we good for me to slide up to like here? Oh, that's really annoying. Good enough. Alright, so then these last two, I'm going to have y is equal to the secant of x, and y is equal to the cosecant of x. I'm honestly not sure if I showed y'all these last year, what these ones looked like. If I did, it probably was simply, here's the parent function and that's it, which is more or less all we're doing with them this time, unless it's something you're doing on your calculator with it. But essentially what happens is if you take the graph of sine and cosine, anywhere there's like a point where it comes and turns around, this one makes a U at that point going the opposite direction. So it just like inverts it. And so these also have asymptotes on them. Let's see. All right, so this one I'm going to go to 3 pi over 2. And these again need the 1 and the negative 1. I'm going to move them, I'm going to move them down a little bit just for the sake of seeing what's happening. All right, so there are asymptotes on this one at the pi over 2's. So this one is the kind of the inverse isn't really the word I'm looking for, but it's the opposite of the cosine one. So this little u is going to be like this, and like that, and like that. The domain for this one is going to be x not equal to plus or minus pi over 2, plus or minus 3 pi over 2, dot, dot, dot. Range is y less than or equal to -1 or y greater than 1. Or well, I guess technically greater than or equal to 1. And then the period, 2 pi. So then for cosecant, this one's going to go out to 2 pi. And it's going to have asymptotes at 0 and then at the pi's. I forgot to put my little 1 and -1 on here. So then this one something like that. And the domain for this one is x not equal to 0 or pi, plus or minus pi, etc. Range is y less than or equal to -1 and y greater than or equal to 1. And then the period is still 2 pi. And there's one more little thing to talk about here. A function f of x is periodic if there is a positive number p such that f of x plus p is equal to f of x for all x. Okay, that's what the upside down a is for all. The smallest such value of p is the period of f. And then just as a reminder, okay, cosine of x and secant of x are even functions. Sine of x, cosine of x, tangent of x, and cotangent of x are odd functions. Alright, so that's all of those notes. We'll do some examples tomorrow, and then you'll have time to work on them, and we'll go from there. And I'll check and see when is the best for a quiz and test for this.
What's the, like, upside down A?
For all.